I am Sam Matthews. I'm currently living in San Francisco, working as a fellow at Code for America, and I'm from Seattle most recently, and have plans to move back in the middle of November. So I'll be sitting amongst you all, which will be nice, and not virtually in this presumably large screen in front with just my head. So, Andrew, do you want me to kick things off, or do you want to do stuff?
Yeah, go for it.
Okay, cool. So thank you, Andrew, for inviting me to chat today at CUGOS. I apologize, my reaction to anybody's hand raising or questions might be a little delayed or completely non-existent because I can only see about half of the room right now, I think. But Andrew asked me to give an update on a project, on a CUGOS project that started about a half a year ago called Dropchop. And it's been getting a lot of work recently, and we have plans to move it into an alpha stage over the next month or so. So Dropchop, what was formerly called Drop and Chop, which is inspired from Greg Corradini, is essentially a browser-based GIS editor based on Mapbox.js and Turf.js. How many people, we kind of like worked on it at the Spring Fling. How many people were at the Spring Fling and saw me talk about this? You can raise your hand. Okay. I can see about half of the people in half of the room raise their hand. So I'll pretend about 50% of you. So where we were then is a little bit different than where we are now, but all with the same intention to make sure that we're basically making it approachable to other people, and so they can work on the project themselves, be a part of it, whether they're a technical part of it or inspiration and design part of it, or if they're giving use cases of what having a GIS in the browser would be particularly useful for. We're basically trying to get everybody involved in what has turned out to be a larger project than originally anticipated. So that Spring Fling, we got a bunch of people committing. I'm going to share my screen now and just kind of go from there. But we got some people to write some code and to think about how a GIS could be better than what we're used to. And we have moved on from there. So hey, Matt Dunbar, give me a thumbs up if you can see this. All right, double thumbs up. Cool. So I'm just going to kind of tell you guys where the updates are and where we plan on going. So let's see. When we left the Spring Fling, Dropchop was essentially just like this little leaflet extension that hooked into Turf.js here, which I can open up, which is a JavaScript library that essentially allows you to pass through GeoJSON objects and parameters and get a response and return of a different geometry. So you can pass in GeoJSON, ask for it to be buffered by a mile, and it returns a new GeoJSON with that mile buffer. So it's cool, it's all in Node, and you can use it on a Node server, but it's also available to be used on the browser. So we wanted to see how powerful it was, and if we could essentially bring all those tools into a visual representation in Dropchop. So if anyone is a GitHub user and has been looking at this repo, I have been like overstepping my bounds of how many commits I should be allowed to give in a day with Dropchop recently. But in order to get towards this alpha, this really vague hypothetical alpha, we are setting kind of like a base set of features and working towards getting those complete by the beginning or middle of October. So I'm just going to give a demo of like one specific use case that we can do now that we were not able to do at the Spring Fling earlier. So this might be, I'll zoom in on this a little bit. It hasn't been tested much for, okay, can you guys still see that? Give me a thumbs up if you can read the words there, Matt Dunbar. Ryan, cool, thank you. Okay, so it's a little big here, but it is a little more smooth looking when you're using it on your own computer. I'm running my local version because the current updates do not exist at Dropchop.io. We are at the bleeding edge of Dropchop right now. So what I'm going to do first is I'm going to basically do that that classic example where we have like a run route or a race route, and we want to figure out how many water stations are within like a certain amount of space of that race route, just to kind of show you those operations, but also show you the new features that allow you to get data and manipulate data into Dropchop. So we're just going to use Mapbox's standard geocoder here. So I'll go to the University of Washington, where you all are. This will also test if, let's see, their geocoder is good. There, well, I'll just go to Seattle. Anyways, we can submit an issue on that later. And I've got a race route that's in Seattle, but I actually have that currently as a gist. So on GitHub, here I'll zoom in as well, I have a GeoJSON file. And instead of having to download that and upload it to Dropchop, I can actually just copy this URL, go into Dropchop, import file from gist, paste that in there, execute, and it shows up. So we've got a race route that's super not real and one that I drew earlier today. And what we want to do are query for, or we want to like basically get all the water points. I personally don't know where all of the drinking water points are here. So one thing that has been implemented in the past 24 hours is the ability to query the Overpass API, which essentially queries OpenStreetMap for nodes and ways. And so what I wanted to do is see if we can query that, kind of like overpassturbo.eu, which is another great little website for querying OSM data, but I wanted to bring it into Dropchop. So you can query the Overpass API. There's a little bit more information about the query language, but we're going to do amenity drinking water, and we'll execute that. Takes a little time, but you can see that we've got some drinking water now, or at least the drinking water spots that exist in OpenStreetMap. So with those points there, I want to rename this layer to drinking water spots. So it's renamed. And what we need to do is essentially create a buffer to the race route. So from race route, we are going to click buffer. If you notice here, one of the big new things and things that are currently like still up for development and discussion are like only allowing for features or operations based on the feature that you want to operate on. So race route right now, things are a little iffy with Turf and what it requires and accepts, but we shouldn't be allowed to do a union with a single layer. So like union should not be clickable, but we are allowed to do a buffer with it. So we're going to do buffer. I'm just going to do 1 mile. You can do all these things and execute. And there's a buffer there. So now I'm going to get rid of the original race route and just have the new buffered race route here. So one final query that we want to do are just get the water points within that race route. So select both of them. Now within is available. We're going to do within, and we want to clip the drinking water spots. So we're going to execute that. It says it's been executed. We can turn them off just to check. And now we just have water spots within that buffer. And then one step further, we can download it as a GeoJSON. Gets downloaded. And then in order to check to see if they work, I'm going to go back to gist and edit it and add like a new file just to confirm that things are working. I think I can click and drag. Did that work? Oh, here we go. I don't know if that's working. This is gist. This isn't me. All right. Well, anyways, I promise it works. It's not clicking and dragging. Here, what we can do is just drag this into Sublime. Copy it all. Paste here. Water.geojson. Updating. It's being a little slow, but at some point we should have a map visual to show us that our points are correct GeoJSON, and we can use them in whatever application we'd like. So voila! That is the little demo of Dropchop right now. So I'm going to stop my screen share here. Well, I'm trying to come back. There we go. Cool. So that's where Dropchop is at. We have a few more things to figure out, and there's much help needed on the showing what operations are available based on the data that you have selected. So if anyone is interested in learning more about the GeoJSON spec and how to iterate through it, feel free to join the conversation on GitHub. But that's where we are. October 14th is the beginning of a conference where I'm supposed to present and demo this tool as a thing out in the wild. So hopefully that is also the day that it is released. Maybe the day before. That would be particularly nice. So yeah, there we go. If anyone has any questions, woo! I think I might be able to hear you guys if you ask something, but if you don't have any questions.
How are you defining functions?
Was that you, Andrew? And can you say that again?
How do you define which functions are available based on the data?
That's a good question. I can show you what we're doing right now and what I have as an idea of something better. So I'm going to move over here. So right now, if you go into the Dropchop source and you go to like these operations.geo, we essentially have like the spec built in. I'll zoom in here. Wait, I'm not screen sharing. That's probably not very helpful. Let me go back. All right, can you see my text editor? Yeah?
Yeah.
Cool. Okay, so if you go into the geo operations file, you can essentially see that we have every, or at least some of the turf operations spec'd out here. So we have like a requirements set. This one is not being used right now. And then we have a minimum number of features, a maximum number of features, a description that we can edit, and then parameters that are essentially used to generate those form options when you select them. So every time you select a new layer, it triggers a kind of just like a publication, a pub sub through the system that I believe is picked up here. So every time a layer is selected, we're going to run geo check on it and essentially take all of the selected layers and loop through their requirements. Or we're going to check what those layers are. So say we have like race route and it is a feature polygon. So we're going to find out that is type feature and geometry type is a polygon. With that knowledge, we can loop through every single operation based in ops.geo here and check to make sure that those match these requirements. Right now, a thing can also be like, say for instance, a long could also work on a feature collection. So we're not like necessarily looking for one match, but we're looking, everything is basically checking for an existence within that array, which is why there are arrays here. So if it matches, if geometry is required, if type is required, we can check those. If they're both required, we can check those. And basically make those buttons available. What is essentially going on is just removing like the disabled feature from those buttons themselves so they are able to be clicked. So that's how they're working now. I don't think that's a very good way. I don't want to be writing a bunch of for loops together. So I actually just posted this about 20 minutes, maybe 25 minutes ago, as I was just thinking. This is probably getting a little granular, so let me know if I should shut up. Let's see. That's not what I wanted. We need to standardize. So there's an issue out here that has basically been me talking to myself about standardizing incoming geometry. There we go. And I've gone back and forth on this issue, which is kind of funny to read. It's just like me going back and forth about what I think should be done and then questioning myself. So I posted another thought an hour ago, I guess, about what I think should be done. And right now we're essentially basing everything, we're taking like the turf functions requirements as like our requirements. So right now if you go look at like turf.within, that only works with 2 feature collections, but it should just be able to work with like a feature collection of points and a polygon, and that polygon doesn't need to be a feature collection. So what I want to do right now, we're just like running the turf operation as is, but what I want to do is run, if I come down here, I want to run like our own operation that is also named the same thing as turf, that essentially allows us to manipulate data in a little more granular way, but then also continue to use like turf functions if they are doing what we need them to do. So that was a long answer to your question, Andrew. Sorry about that. Cool. Well, I am recording my screen right now, and if anyone has any more questions, feel free to ask them on GitHub, post them in the CUGOS Google channel, or I don't know if you have my email, send me an email. Yeah, thanks for listening. Or is there another question? Again here.
I'm wondering if you have in mind for
Cool. Sorry, can you say the question again? It's a little spotty.
who might be the target?
Oh,
like a professional or web developer? Just anybody.
Sure. Yeah. So it's our just to make sure I heard you correctly. Who is the target audience like to use the tool? Cool. I have an assumption of who the target audience is. I don't know if I have a true knowledge of who the target audience is. My hope is that it's for people who, like journalists, for instance, who have like small amounts of data and need to do quick operations to make them available for visualizations that they're throwing on their website. I definitely recognize that like turf in the browser is not the best way to query like 500,000 points because it's just going to break your browser. But for little visualizations that are just using like state boundaries, for instance, and you have like points for boundaries and you want to sum them up into those polygons, I would love to be able to. I would love to see Dropchop be able to produce that output and just kind of do small scale GIS operations. So yeah, I would say the users would be people who need geodata but don't necessarily have like the money for an ARC license or have the capacity to download QGIS and have that as one of their main go-to tools. So yeah, if you have any other potential use cases or people or like examples that you think would be useful, I'm kind of trying to find those to like then build the tool off of them, just because that's a good way to get direction for it.
Sounds great.
Cool. All right.
Thanks, Sam.
Cool. Thank you guys. I'm looking forward to being back in the Pacific Northwest to be in those meetings with y'all. All right. I'm going to hang up here. Thanks, Andrew.